Hi everybody, this is your video on triangle similarity criteria. So I'm going to kind of walk you through what these criteria are. They're very similar, no pun intended, to the triangle congruence criteria that we looked at. Remember, with the sides and the angles? Okay, and I'm going to do some examples for you, and then I have one more video that has some practice problems with triangle similarity. If you're looking at the slides that we normally work through, there's also some extra bonus slides and examples on something called the triangle proportionality theorem, which I'm not going to test you on this year, but if you'd like an extra challenge and you would like to learn a little bit more about triangle similarity, then you can definitely take a look at those slides, and I'm going to try to find you some videos and things that that other people have made that go along with that idea. So with that, let's go ahead and jump into it. Okay, so what I'm hoping you remember from when we talked about triangle congruence criteria was that we had 5 different triangle congruence criteria, right? We had SSS, SAS, ASA, AAS, and HL. Okay. And then I mentioned to you that there were a couple that didn't work, but these were our triangle congruence criteria. So the cool thing about triangles is you can do the same thing for determining if triangles are similar. So rather than having to check all 3 pairs of angles, right, all 3 sets of congruent angles, and all 3 sets of proportional sides, remember, meaning that you can pair them in fractions and the fractions are equal. Okay, so rather than having to check 6 things, you can check just a couple of key things, right? And then if you have the right combination, then you are able to say that the triangles are similar without having to check the whole thing. So lucky for you, there are only 3 triangle similarity criteria, so less to remember, which is always good. So your 3 triangle similarity criteria are angle, angle, right? Some people will call it AAA. But if you know 2 angles in a triangle, then you automatically know the third, because all of the angles in a triangle have to add up to 180, no matter what the triangle is. Okay, so if you know that you have 2 sets of congruent angles, then the triangles are similar. Okay, and then the other 2 should look pretty familiar to you. SAS, where you have 2 sets of proportional sides and a congruent angle that's trapped in between them. And then the third is SSS, where you have all 3 sets of proportional sides. Okay, those are the triangle similarity criteria. They're going to guarantee that you have similar triangles, meaning same shape, different sizes. Okay, and what we use these for oftentimes, like architects and builders and lots of other professions, use these proportions and these rules. Graphic designers, tons of different things. Professions use this idea for something called indirect measurements. Okay, so oftentimes, especially when things are very large, it's very difficult for us to measure them directly because we don't have tools that are large enough or wide enough to measure exactly how long something is or how tall something is, or, things like that, right? So if we can build models that are the same shape as the thing that we're trying to measure but a different size, right, then we can use our knowledge of proportions in order to figure out what those lengths are, without having to actually measure them. So pretty cool. Okay. Okay, so the one thing that you might be wondering about is, okay, I have SSS and SAS for both similarity and um, and congruence. So how do I know and how do I tell which is which? Okay, so just as a refresher, a reminder for you, if you're dealing with SAS and SSS congruence criteria, the corresponding side lengths are congruent, right? They have to be exactly the same. In the similarity criteria, the corresponding side lengths are proportional. Okay, and what that means is that um, you have to write fractions with the corresponding sides, very similar to how we wrote scale factor fractions when we're talking about dilations, right? Same idea. And those fractions have to be equal because if they're not, then that means the shapes are different. So it's a completely different shape. Okay. But when you're dealing with either of these, similarity or congruence criteria, the corresponding angles must be congruent. Okay. So angles are always congruent, right? You're always checking to see if the angles are the same. Okay. It's only the sides where it differs, right? So congruence criterion, side lengths must be congruent. Similarity criteria, side lengths have to be proportional. Okay, and I'm going to show you how to write those proportions and how to solve those types of problems in just a second, okay? But I have some strategies for you, right? And a couple of different methods that you can use to solve triangle similarity problems, okay? So for angle, if things are not marked exactly for you, very similar to the triangle congruence proofs, there were some things that were hidden and they weren't marked. So we have to figure out what they are, like whether or not you have congruent angles using our knowledge of um, our knowledge of geometry and things that we know about angles. So the key thing to look for, okay, key things to look for are vertical angles, okay, because those are often hidden, right? Vertical angles, shared angles, okay, meaning that you have like one triangle inside of another triangle, which I'm pretty sure I have an example for you on here that looks like that. So I'll show you what I mean by that. Shared angles, and use the triangle sum theorem, okay, where all angles in a triangle have to add up to 180 degrees. Okay, bonus, also look for alternate interior angles with parallel lines. Okay, so that's a little bonus, which I didn't have on here because it doesn't show up very often, but in some problems that will show up. So you can get congruent angles looking for these couple of things, okay? For side, what you're looking for is 3 sets of proportional sides. So the way that you do this, okay, the way that you solve these problems is you always match the shortest sides together, the middle length sides together, and the longest sides together and write proportions, okay? Meaning write fractions, okay? And there's 2 methods that you can use to figure out if those sides are proportional. Okay, method 1 is to write the fractions and reduce the 3 fractions to see if they're equal. Okay, all 3 have to be equal, right? If you have 2 that are equal and 1 that's not, then those triangles are not similar. All 3 of them have to be equal. Okay, if you are not a fan of fractions and don't like reducing fractions, if that's not your jam, then you can also use cross multiplication. You have to use it twice, okay, to see if you get equal numbers. And I'm going to show you what I mean by that when I do some examples for you, okay? For SAS, you're still looking for 2 sets of sides and an angle, a congruent angle that's stuck between them. So again, you can use the same methods that you use for SSS. It's just you don't have to do, like, you don't have to use cross multiplication twice because there's only 2 pairs of sides that you're checking. You would only have to reduce 2 fractions instead of 3, right? Because you only had 2 sets of corresponding sides that you needed to worry about. So when you do SAS problems, you have to write proportions. Ooh, if I could spell, that would be awesome. For the 2 sets of sides and check to see if those proportions are equal. Okay. All right. So let's try some examples. Okay. And I'm actually, give me a second to reset some stuff and make the notes part a little bigger on the right side and zoom in a little bit. um, so that so that you can see this a little better. So I'll be back. Give me one moment. All right, y'all. So let's do some examples here. You can kind of see them worked out a little bit on the left side of the screen because I have the key up there, but I'm going to walk you through how to do these different types of problems. So we're going to look at angle first. Okay, so all we have to look for is two corresponding congruent angles. That's what we're looking for. Okay, so here in number one, we actually have numbers that we're dealing with here. So I can see one set of angles that are congruent, right? So I have one set, but I need another. Obviously, the 74 and the 31 are not congruent, but I know that all angles in a triangle have to add up to 180. Right? So I can see if this missing angle right here is 31. If it is, then I have two sets of congruent angles. Okay, so I'm going to do 75 plus 74, which is 149. And then I'm going to subtract that from 180. 180 minus 149 equals 31, which is what I wanted. So this angle is 31, which means I now have two sets of congruent angles. So I can say yes, check that these two triangles are congruent, or not congruent, sorry, that these two triangles are similar because I have two sets of congruent angles. So I need to write my triangle similarity statement, okay, very similar to the triangle congruence statement. We'd have one triangle is equal to another triangle, okay, but here, so this is triangle ABC, and I'm still going to go in the same order, so the angles still have to match up. So A went with D, B goes with E, so D, E, and then C goes with F. And then rather than putting a congruent symbol in the middle, you just put the squiggle, which is called a tilde, right? Because that indicates similarity right there, okay? All right, then number two is a pretty simple one. It's a pretty easy one. There's no numbers here, but I can mark some hidden angles. So these angles here in the middle that are both connected to X are congruent because they are vertical. Okay, so that means I definitely have similar triangles here. Okay, obviously they're not congruent, they're different sizes, but they are the same shape. Okay, so I can say, check, yes, those are similar. So I'm going to write my similarity statement. So whatever order that I write the first triangle in, I have to write the second triangle in the same order. So if I write triangle VWX, I went from one mark to no marks to two marks. So I have to do the same order with the other triangle. One mark, no marks, two marks. Okay, so triangle YZX is the same order, and then I'm going to put the little tilde in between them. Okay, so there's your angles that are congruent. So that's angle similarity. Okay, so let's look at side similarity next. Okay, so with this one, you have to have all of the corresponding sides have to be proportional. Okay, and I told you there were two methods to use. Okay, so I'm going to show you the first method using the reducing fractions, and I'm also going to show you the second method that deals with cross multiplication. People typically like the cross multiplication method a little bit better. Okay, no matter which method you're using, you should always start by matching the sides together, right? Match the sides that correspond. So smallest side goes with smallest side, medium side goes with medium length side, and largest side goes with largest side. So I'm going to write my fractions, okay, with my corresponding sides. So this is method one. Which is reducing the fractions, okay? So I'm going to write my three fractions. 3 out of 6, 4 out of 8, and 5 out of 10. So I want to know, are all of these fractions equal? Right? That's what I'm trying to figure out. Question mark, question mark. Are they equal? Okay, so I have to reduce all of them. So the largest number, the largest common factor between 3 and 6 is 3. So I'm going to divide both of these numbers by 3, right? Reduce this fraction. So 3 divided by 3 is 1. 6 divided by 3 is 2. So 3 6 becomes 1/2. Greatest common factor between 4 and 8 is 4, right? 4 divided by 4 is 1. 8 divided by 4 is 2. It's looking good so far because I have those that are equal. And then same thing with 5, right? So greatest common factor between 5 and 10 is 5, right? That's the biggest number that goes into both 5 and 10, right? So 5 divided by 5 is 1, and 10 divided by 2 is 1/2. So I can say, check. I have all 3 of these proportions are equal. So that means that the triangles are similar, okay? Now I'm going to show you the other method, which is cross multiplication. Okay, so you still have to write your 3 fractions. So 3 out of 6, 4 out of 8, and 5 out of 10. Now, what you can do with this, okay, is pair your fractions together. So you're going to have to do this twice. So you have to check, like this first side, for example, against the second proportion, the second set of fraction, or second set of numbers, second fraction, and the third one, right? You can't just check one because then this third one might not be equal, right? So you have to check them all. So what you do is you set these equal to each other, and then you use cross multiplication, right? Which you may remember as drawing the butterfly. And the goal here is to have the numbers be equal at the end. So 3 times 8 is 24, and 6 times 4 is also 24. Okay, so I'm good there. Check, right? But I also have to check, say, this first one, 3 out of 6, against 5 out of 10. So I'm going to do the same thing here and see if I get equal numbers. Okay, so I have 5 times 6 is 30, and 3 times 10 is also 30. Okay, so I'm good. Check. Now, obviously, these equations are not going to be equal to each other. You're going to get different numbers with each equation that you write, right? With each pair of fractions, right? Because the numbers change. That's not the point. The point is that you get an equality at the end, right? Even if the two numbers that you get within the two sets are different. Most of the time, they will be different, okay? So if both of these give you equalities, then that means that yes, these triangles are similar. So if I wanted to write my similarity statement, I would say triangle QPR is similar to triangle TSU, right? Following the same path. Top, right, smallest, middle side, smallest side, middle side, right? They go in the same order. All right, so I'm going to pause the video. I want you to try number 4, using whichever method makes the most sense to you. All right, folks, so go ahead and check your answer against mine. Most people like to use the cross multiplication method because it gets rid of fractions the fastest, and poor fractions have become the ugly stepchild of mathematics. Everyone has PTSD when it comes to fractions, so most students tend to choose the cross multiplication method, even though they have to do it twice, just because that way they can get rid of the fractions faster. So I did that. So I paired my smallest sides together, so 30 and 24, my middle length sides, 32 and 25, and then my longest sides, 35 and 28. Now, when I wrote an equation with my smallest side proportion and my medium side proportion, and I did the cross multiplication, I got two different numbers, right? 30 times 25 is 750, and 32 times 24 was 768. So I got two different numbers, which is not what I want. So what that means is that these triangles are not similar, okay? All right, so let's take a look quickly at SAS similarity. So this is like a combination of the other two. So you have to have one set of congruent angles and then two sets of corresponding sides that are proportional, making sure that the angle is stuck between the two sides. So you have to check the congruent angles. So say here in number 5, I have angle K and angle N. Those are congruent. Okay, so I have my angle, and then I have to, similar to what I did here with SSS, I still have to match my smaller sides together and then my larger sides together and write proportions with those. Okay, so I have my angle, right? I can check that part off, but I have to check the sides. So 8 goes with 6, so 8 over 6, and then 20 over 15. I want to see if those are equal to each other. Okay, I'm going to use method 1 here because I used method 2 and kind of talked you through method 2 in the last one. So greatest common factor for 8 and 6 is 2. It's the biggest number that divides into both of those. So 8 divided by 2 is 4. 6 divided by 2 is 3. Biggest number that goes into both 20 and 15 is 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. So I have equal fractions, check, which is what I want. So I can say that yes, these triangles are similar, check, right? So my similarity statement would be triangle JKL is similar to triangle MNP. Okay. All right. Then in this last one here, really quickly, I want to point out to you that this is what I meant when I was talking to you about shared angles. Okay. So you can kind of see in this picture that you have got two different triangles, this smaller one here, and then this larger one, right, which covers this whole thing, right? So these two triangles have this angle in common, angle A. And as we know that any angle that is shared, or like any side that is shared, those have to be congruent, right? So that angle is congruent to itself. So here, even though it's not marked because it's shared, I know that those two angles are congruent because it's the same angle. Right? These almost remind me of Russian nesting dolls. I don't know if you all ever had those or played with those, where you have like a smaller triangle inside of a bigger triangle. Right? With the Russian nesting dolls, it was like smaller dolls inside of bigger dolls that you could take apart and things like that. Okay, so the last thing I have to check is my fraction. So my smallest side in the small triangle is 12. That goes with 21 in the other one, so 12 over 21. And I want to check, does that equal 15 over 25? Again, I'm going to use method 1 just because I don't really want to do this multiplication because I don't have a calculator with me, and it would take me a second to do that multiplication. So I'm going to use method 1 and reduce these fractions. So biggest number that goes into both 12 and 21 is 3. 12 divided by 3 is 4. 21 divided by 3 is 7. Biggest number that goes into both 15 and 25 is 5, right? 15 divided by 5 is 3. 25 divided by 5 is 5. So those are not equal. So we would say that these are not similar. All right, y'all. So that is it for this notes video on triangle similarity. I hope that those examples helped you and will help you with the practice problems in the next video. So I'll see you guys in the next one. Bye, everybody.